Hello, everyone, and welcome to the second event of the series on Handshake. I'm Laura, and I'm the Media and Innovation Manager at Wyss in New York. Handshake is an interactive robotic installation that invites participants into a moment of connection and digital intimacy. It was developed by the Swiss design duo AATB, whom we'll have the pleasure to hear on this panel discussion today. If you participated in the launch event on May 28th, then you know that this project is a result of the limitations set by the pandemic. We were initially supposed to collaborate with AATB for a physical exhibition at Wanted Design in New York this spring, but because travels and physical gatherings have become impossible these days, we decided to work under these new conditions and develop a new project anyways. So in view of this, I would like to thank our partners, the Swiss Consulate General in New York and the Federal Office of Culture for their close collaboration on this project. I would also like to thank President Switzerland, Swiss Next San Francisco, Pro Helvetia, and Wanted Design New York for their generous support. And last but not least, a big thank you to the Swiss Next Network and the teams who worked behind the scene to make this project possible. This is a panel discussion on robotics and the human touch. And today we're honored by the participation of 4 industry experts from Switzerland and the US, in addition to Andrea and Thibaut Brevet, who formed the artistic duo AATB. The topic of conversation will focus on the panelists' interpretation of the robotic installation Handshake, created by AATB, and then feed into an exchange on the future of robotics and human-robot interaction in light of the COVID crisis. It is now my pleasure to introduce you to Steven Rader, who is Deputy Manager at the NASA Center of Excellence for Collaborative Innovation and will be a moderator for this panel. Steve focuses on the study and use of curated crowdsourcing communities that utilize prize and challenge-based methods to deliver innovative solutions for NASA and the US government. In 2015, he was named as one of the 20 challenge mentors for the US Government Services Administration's Prizes and Challenges government-wide community of practice. Steve speaks regularly about NASA's work in crowd-based challenges and the future of work, both publicly and internally to the NASA workforce to promote the use of open innovation tools. He has a mechanical engineering degree from Rice University and has worked at NASA's Johnson Space Center for 30 years. Steve, the floor is yours.
Thank you so much, Laura. It is just a pleasure to be here and part of this panel and part of this exhibition and effort. It's a really exciting time. I am obsessed with the future and with the future of society and where we're going and the future of work. And automation and robotics are really near and dear to my heart. I've done a number of challenges with our Robonaut team and with several of our NASA robotics teams, and they're always the most fun, and I really enjoy it. So this is something that I think is an important conversation. I think it's something that we really need to engage in as a society, not only in terms of how robotics are starting to blend into our world, but and become part of our lives, but also how under the global pandemic, how they can help us connect to each other and remain connected. So that's my own little self-intro. With that, I'm going to introduce our panelists, who are quite amazing. I'm going to start with Professor Jamie Paik. She is the founder and director of the Reconfigurable Robotics Labs of Swiss Federal Institute of Technology and a core member of the Swiss National Centers of Competence in Research and Robotics Consortium. At Harvard's Microbiotic Robotics Laboratory, she actually started developing unconventional robots that push the physical limits of material and mechanisms. Her latest research efforts are in soft robotics and self-morphing, this is the best, robogami, right? Robot origami. So it just kind of blows your mind what she's working on. Her work has been published in Nature and in Science in multiple robotics journals. She's co-founded a startup called Foldaway Haptics, whose robots are actually featured in a 2019 TED conference talk, and you should check that out because it's pretty amazing. So Jamie, if you'll take a minute and just kind of expand on what I've said about you and tell us a little bit more about what you're doing.
That was an excellent summary of what I'm doing. So if I were to just add a bit, since I have a minute. So my group developed and create solutions for unique robots. But why are they unique? Because we want to improve human to human, human to robot interfaces. So we understand use of classical nuts and bolts, joint and link based robotic design, but we know that they can be limiting. So that's the reason that we really push the physical limits and material limits for additional functionality by making links modular, like Legos, and making also my robots being reconfigurable, like origamis.
Oh, that's amazing. If you get the chance, go check out her demos and her actual pictures of these things. They are just fascinating. And the haptic feedback pieces are just really going to be key to the human robotic innovation. So I'm just happy to be here with you, Jamie. This is amazing. This is a huge all-star panel that's really impressive. And Roland Siegwart is professor for autonomous mobile robots at ETH Zurich, and is founding co-director of Technology Transfer Center, Wyss Zurich, a board member of multiple high-tech companies. Roland has studied mechanical engineering, has spent 10 years as a professor, has held visiting positions at Stanford University and NASA Ames, and for a time was vice president at ETH Zurich. He's an IEEE fellow, a recipient of the RAS Pioneer Award, the RAS INEBA Technical Award. He is actually among one of the most cited scientists in robotics worldwide. He's co-founder of more than a half dozen spin-off companies, a strong promoter of innovation and entrepreneurship in Switzerland. Just please welcome Roland Siegwart. Roland, tell us more about you and maybe even about some of those fascinating robots behind you.
Yeah, thanks very much for this nice introduction. Of course, if you are among the most cited scientists in the field, which means typically that you're growing older. So that's, of course, the work we did in the past. So I typically tend to say that I have the chance in my life to do what I was as a kid, as a young fellow, always dreaming of, building robots, intelligent machines. And so we are working on the design of different type of robots for different type of environments. So you can see above me, for example, a VTOL system, which is vertical takeoff and landing and flying platform, which is a fixed wing, only wing system. Or in the back, you can see also a swimming tuna. So we have worked on most different locomotion concepts, and then mainly also on the whole navigation. Meaning this starts with localization. You have to perceive the environment, localize in the environment, and then automatically explore the environment, build maps. And this work has also resulted in a couple of startup companies. I'm extremely excited always to see and to work with young people which are so energetic to really move forward. And meanwhile, out of my lab, we have about 15 startup companies which were created and were successfully continuing.
That's amazing. I have to say, as a mechanical engineer, this is like my dream panel, okay? Because this is really cool. Okay, I'm going to take a risk here, and I'm going to introduce our next panelist. And if we do it just right, she will magically appear just as I finish and be able to talk. But she's running a little bit late, and hopefully will join us soon. But her name is Andra Keay. She is the managing director of Silicon Valley Robotics, which is a nonprofit industry group that supports innovation and commercialization of robotic technologies. Andrea is also co-founder of the Robot Launch Global Startup Competition and is a mentor, investor, and advisor to startups, accelerators, and think tanks with a strong interest in kind of commercializing socially positive robotics and AI. She shares a lot of that on her site, the Robot State site. Andrea co-founded RoboHub and Robot Garden, and started the Women in Robotics community. So she has done a lot, and I think you will enjoy her, and you can find her on the web with some great talks as well. She's a TEDx talk out there. Did my magic work? Did she magically appear? My magic's off today. Sorry, guys. Andra will join us a little later in the conversation, but that's okay, because that means I get to introduce our actual stars of the show today, the developers, the collaborators who put together this exhibition, Andrea and Honor and Thibaut Brevet. They have been collaborating together in practice since 2018 as designers. Andrea was born in Zurich, graduated from Zurich University of the Arts in 2008, with a BA in visual communication, and 2012 from EPFL in Lausanne with an MA in art direction type design. Did I get that right? Okay, I'm gonna get the nod. Since 2014, she has been collaborating with Martina Perrin and Anna Perrin in Studio for Art Direction. Thibaut Brevet was born in Lyon, France, and graduated from EPFL in 2012. I assume that's where you guys met, in EPFL. Yeah, okay.
Yes.
With a BA in graphic design, and in 2015 got a master's in visual arts. Has been developing a practice at the intersection of art, engineering, and design that is clearly relevant in this exhibition and comes through, and has been programming websites since 2012. Their joint practice as AATB has been developed around the idea of non-industrial robotics. They started experimenting with industrial robotic systems such as robotic arms and industrial automation processes. And together they've been developing works that are exploring the human-machine interactions through the lens of kinetic and interactive devices. They have actually been nominated. This AATB has been nominated for the Swiss Design Awards for 2020, and we are really excited to have you guys here and excited about your exhibition. So with that, why don't you tell us a little bit about the installation and introduce us kind of to what it is and what you intended, and we'll start there.
Yeah, so basically Handshake is an interactive robotic installation where people can physically interact with each other. So basically two strangers can touch each other without physically touching, but they can touch when using Handshake. So how it works. We have two robotic arms that are installed in our studio, and we have a live stream of our studio, and people can go on a website and they can take control over one arm, and then they can control the arm, and at the end of each arm there is a huge hand. Basically they can shake hand with another person across the globe.
Yeah, and this project is a continuation of a lot of research we've been doing since, actually we started collaborating almost 10 years ago, but informally, and AATB showed up like about 3 years ago. And we've been always interested as designers to explore the possibilities allowed now by technologies that appeared, such as Arduino, for example. So Arduino is a very tiny microcontroller platform that was developed for, let's say, non-academics or non-technical people to use like electronics first programming, but to build robots or to build machines that can have like sensor inputs, behaviors, and actuators to actually affect their environment. And so I think it's quite interesting for us because the panelists tonight are tonight, wherever people are, it's very for us very impressive, and we feel a bit like being the funny kids that are playing around now with technology, while you are insanely also successful in your practice. But from where we come from as designers, like technology or robotics is something so far out that it feels like you can just never work with this. It's something completely out of reach. But along the last 10 years, we've been slowly taking hold and putting a foot in the door of very just like at first blinking LEDs, and then slowly building up our knowledge of like interactive systems, like suddenly buying a second-hand robot on Craigslist, and then having no clue how it works, and then just no background whatsoever in robotics. Slowly got to understand how the whole thing works, the programming of the robot works, and then now this project for us is also a huge step forward because we are entirely self-taught. We have never learned anything in university related to robotics, and this project for us is completely done by YouTube tutorials and PDFs on Google. So yeah, for us it's not just Handshake, but it's interesting. It's also the fact that robotics are entering new territories. Today, the robotics are becoming more and more accessible, and we are a bit a symptom that robotics are like showing up where you don't think so, or people are taking a hand of robotics that you would not expect before. So yeah, this is probably a long intro for a Handshake, but yeah, Handshake is really about connecting people everywhere in a kind of light and funny way, but then it also raises a lot of new questions about robotics today and the new actors that are in the game.
I love that, and I will say, one of the things I love about it is that you did self-teach. One of the things I work a lot is the future of work, and what we're finding is lifelong learning is at the core, and people are finding new ways to actually do that. You mentioned YouTube videos and the rest, so it's a fascinating that the kind of makerspace movement is part of what you're doing, because I think that's the engine behind a lot of what's going on. So we can maybe bring that into the conversation. Andra Keay, you have come right, I swear it was like 3 seconds later than I did, right after I had finished introducing you. So this is perfect. I will turn it over to you. I have introduced you, so I gave a high level of what you've done, but why don't you just give us a little bit of a taste of what you're working on now and what some about yourself.
Thank you so much, Steven. And I have to say, I really commend AATB. I love the story about Handshake as much, if not more than Handshake itself. And at a very, very deep level, I've gone from human-robot interaction to really trying to understand the spread of robotics into society broadly. And one thing is clear to me. First, we don't have enough people who understand robotics. And the fact that people can self-teach now is fantastic, because if we count the capacity of our universities and our community colleges to turn out mechatronics engineers, roboticists, computer scientists, we're going to fall short of the capacity that is needed. And I place my faith in the fact that we're now capable of designing technologies that can teach us. So, you know, I really think that this is the extension of an intelligent technology, is something that is designed well enough to kind of carry its own user manual with it. And that's really a tribute of good design, but it's also a tribute of the creative imagination and willingness to experiment with technology that I think is just so essential. And it teaches us completely new ways in which these technologies will be useful in society. At the heart of things, I am an interface between the robotics industry and society as our organization, Silicon Valley Robotics, which is a non-profit formed by the robotics industry itself to support the really early stage of innovation in robotics and to support its commercialization and rollout into society. And as a kind of interface or translation layer, I think that I have to respond to people saying, but what are all these problems about, you know, that robots are going to cause? And the best way to avoid problems with robots is to focus on robots doing things that we choose them to do, and that we want them to do, and that we need them to do. And then I believe any worry about robots doing bad things becomes very secondary. So the more we have people involved in use cases of robotics, the more it is pretty much a ground upwards rollout of robotics, then the better it is for society in general.
Oh, that's wonderful, Andra. I just love hearing her speak. No matter, like, it doesn't matter what you say. I just, you always have just amazing insights. Let's just go around the panel real quick and get some reactions. If you can each speak to kind of your experience with Handshake, because I believe you have each kind of gotten on and experienced that. And then talk a little bit about how that experience is related to your work in robotics. Andra, I know you just touched a little bit on that, but I'll give you an opportunity to do a little bit more. But let's start, Roland, let's start with you. Talk a little bit about your experience with Handshake and how it relates back to your work.
Yes, of course, it was a wonderful experience. I always liked really that non-roboticists really start to experiment with robots. I think robotics and general intelligent machine can help us really to extend our capabilities, to help us to get in touch with people which we probably cannot get in touch because they're too far away. And I was actually involved in robotics and internet for about 20 years ago, where we had a couple of projects where it was about telepresence and teleoperation of systems, which was somewhat with this vision that you can go to places where you probably cannot avoid to go and not have not enough money to go, or there is some restriction. And of course, with Corona, we have now a situation where people would like still to explore probably New York, but they cannot do it. And I think this technology will help us in the future to do things through technology, which is still extremely emotional, where we can really get into touch with this. We know a couple of examples where people are at conferences in telepresence with a robot where they can move around. I think this experience is pretty nice, and it is also shown that the people at the conference recognize really this person being present physically, even if they are telepresent. Yep. And I think there will be more of these elements. Of course, in parallel, we have this virtual and augmented reality, where we actually also doing a lot of work, especially on the motion estimation, and which will be an additional element, which allows us to experience very new elements. And I think it's nice because it's always in link with the real. So augmented reality, I think, is much more exciting than virtual reality. And robotics is actually augmented reality with physical intervention, or at least a capability to intervene in a distant place physically.
Yeah, that's wonderful. Yeah, I want to come back to that whole augmented virtual reality intersection, because I think it has some really powerful stuff. But let's see, Jamie, you want to weigh in?
I think this one's timed perfectly, because I really second what Roland just said. And if I were to take it a little further, so you're saying the physical presence is really important. Despite all this virtual reality and augmented reality being so well done graphically, we still miss something. And that something is actual social cues. This is why during the lockdown and confinement, people actually want to go out. Even though you have all the access to the telephones and Zoom calls and house parties, you still want to go out. Why? Because you need that physical interaction. You need to feel the aura of the person next to you. It doesn't matter if you just see the face, which is a lot better than not seeing it. It's much better than telephone, but you need a face. But after that, you want the video. And after that, what do you need? I think the future is really in next generation of virtual reality is augmented reality. After that, I think it'll be tangible reality. You want to feel what you're seeing, and you want to be part of the experience. And this AATB's work shows the first step toward it, showing the experience of physical reality. But even though you guys say handshake, the robots don't really do the handshake just yet. You do a high five, sort of. But I think what can be quite interesting is if the person who's operating the robot actually gets to do the handshake with another person who's operating the other robot, and feel the sensation, how strong the handshake is, or how it's missed. And that's called haptics. You actually get the feeling of what the other person's feeling or the robot is feeling. That sounds really weird, but that's critical when you actually want to improve human-to-human interaction in virtual world and in remote places, as well as human-to-machine interface. So that really hits a home run for me, because that's the type of robot we are developing. how to improve this human-to-human interaction and human-to-robot interaction. And I think you guys did a really amazing job to show the importance of it. People just get engaged. It doesn't matter if I feel the handshake or not, but just seeing it happening is so exciting. Imagine how much more we can get and feel if you actually get to feel what's happening.
Yeah, and I get really excited because they're doing this as makerspace type of work, right? So I'm getting really excited by what you're saying because I know you're working on haptics as a deliverable, as something that anyone can have. And it would be great, just like Arduino, you can go buy an Arduino board for, $35, being able to buy a haptic glove for, $50 or something. That's going to start to really change the way the makers are starting to use robotics and really interact. And that's when we're really going to see the interaction start to change. Andra, you have anything you wanted to add?
That is starting to ripple out. And I was going to say, we know how powerful haptics is in teleoperation, in medical and surgical robots, but they're a much more expensive level of system, highly sophisticated. And the reason they work so well is because of that feedback, that touch feedback. But at the same time, the video game industry is pushing the development. And I know a number of startups that are working on different ways of incorporating forms of haptic feedback, whether it's through the use of sound waves, whether it's through the use of gloves and vibration technologies, or a whole range of things. In fact, I think you can go now and buy gaming gloves or musical instrument gloves from, say, Bebop, for example, that give you some of that interaction. And we need to see haptic sense dropping in price so that it can be adopted by everybody. And really what paved the way for robots navigating in small areas was the drop of the price of indoor navigation sensors like the Kinect from Microsoft, which was originally, of course, for gaming rather than for robotics, but it really heralded a renaissance in the ability of people at maker level to develop navigational robots.
Yeah, I was floored, and this has been like 5 years ago, maybe 10, when I bought my Nito robot vacuum cleaner, and it had LiDAR included in it that it would laser map out my room and then vacuum all the way up to all the little pieces. That navigation in something that I could buy for a couple $100, amazing. And that is starting to really become the building blocks of what people can do. And the technology's coming along in some really interesting ways. I want to come back to this virtual reality piece because I think what's interesting is virtual reality and haptics would allow you to basically immerse yourself in a location where you are not and interact with people who are there but have to actually interact through a different piece. I would actually argue that the AATB is a little bit of a virtual reality. That screen is basically helping you to see a video representation of what's there, and you're both interacting with it. It'll be interesting to see the combination of VR, haptics, and robotics, and how they really create a seamless space-time continuum, if you will, of an experience, right? That starts to connect people in more and more real ways and in some augmented ways, right? That's what's really interesting too, because it's going to go beyond just touch, and it's going to, start to have multispectral imaging available and different ways to experience that interactions. So let me go, let's see, to Jamie. Let's go to Jamie again. Do you think that the virtual human interaction through robots will ever replace the in-person interaction? And follow on to that, how can we actually achieve digital intimacy via robotics?
Great question. I do not think robotic interaction will never, ever replace actual human-to-human contact and interaction. That cannot be replaced. Just for the fact that unless you're cloning a person, having that cloned person do exactly what you want it to do, maybe that's a different story. But no one's going to call that a robot. That would be a cloned person. That being said, if you want to make a robotic interface that simulates certain physical interaction, that means you have to get this abstract abstracted version of what you want to feel. So currently, most of haptic interface just focus on the hand because hand has the most sensitive skin resolution. But if you don't have a hand, or if you're typing away on your computer, it's no longer a viable solution. So I would like to suggest that we expand the haptic interface to go beyond hands. Anywhere on your skin, don't go too crazy there, and wherever you want to feel additional interaction with a remote person, that's actually gives you extra cue, physical cue that you get to incorporate it into your experience. So it doesn't even have to be very elaborate or sophisticated. Having a couple of cue points, 5, 6 points, or grid, that does not really reflect actual interaction with objects, can still give you a very rich information that you didn't think was very useful. Just to take an example of your cell phone vibration, you can set different ringtones for a different person, and you know intuitively this is not the same person who's calling, just from the frequency difference. Imagine how much more information you can get if you were to change the frequency and force and location.
Yeah. This is a really interesting area, and I love that you brought in cell phones. We don't think about the fact that our cars are an extension of robotics as well, that we use all the time. And what's fascinating is in newer cars, they're putting haptics all over the place, right? Now, if you get on a new rental car, the steering wheel vibrates, and the back, you get out of your lane and it vibrates. Haptic feedback is becoming part of it. There's some really interesting work that David Eagleman, a neuroscientist at University of Houston, did, where he made a vest that you would wear that would vibrate at different points. And he actually used machine learning to teach people how to predict the stock market using that vest, because it's kind of like the way cochlear implants reprogram your brain. That pattern started to reprogram people's brain to have additional senses. Fascinating stuff. I could go on about that. Anybody else want to weigh in on that question?
I want to follow on that, because that's some of the things that inspired me to start studying the interface of human and robot technology were early experiments around, say, for example, the magnetic field belt, which provided an augmented sense. And there was some evidence that after wearing a belt that vibrated when you faced true north, people started to reactivate what birds have, which was a sense of the magnetosphere. And I just find those concepts fascinating. But to relate this back to the points that Jamie was making about isolating the key pieces of information that are required, or abstracting out those concepts, this is where I enjoy artwork in the field of technological art so much, because I believe that artists frequently cut to the chase. And the thing that made Handshake work for me was the fact that the other hand was identified with a name and a location. And so I then personified the interaction in a way. And this is a very, very simple abstraction that created a very different approach. And I was able to compare it because I was playing with the hand on my own for a little while, and then somebody joined. So I was able to really kind of think about the differences there. And I think there have been two conclusions that I've come to through the COVID period. One is that teleoperation is definitely where the money is going to be in robotics. And on the whole, we're going to want that to become as seamless as possible. And we see this in delivery robots already. People don't realize, they think it's an autonomous robot, but it's often being directly teleoperated, or at least partially teleoperated. And so we're going to see this kind of divided control happening a lot. The second one is that we've had two camps around intimacy and technology. And generally speaking, we've all agreed that you can't replace humans, but that's kind of been a blanket statement that you can't achieve intimacy or emotion through the use of technology replacing people. And I think the coronavirus crisis has forced us to be communicating via technological means in some very intimate and emotional situations. And we've realized that we would rather have that than no communication, And not only that, but there are some times in this period where we've achieved an even greater sense of intimacy, perhaps, in a communication that wouldn't have happened directly in person. And there have been some studies from robot artists and human robot interaction researchers around our willingness to trust robots. So for example, Blabdroid from Alex Rebin, where people were telling their deepest, darkest secrets to a little cardboard box robot. And there are clear principles behind that in some ways, which led me to spend a lot of time really looking at the concept of empathy. And I believe empathy is something that we can construct into our into our technologies. And it's very different from what we assume is necessary for, say, sympathy. Sympathy, which is where what is on the other end actually experiences the feelings. But empathy is a case of taking the right action to recognize that somebody has an emotional position and then to take the right action in response to that. And I think we can do a lot in the future for actually providing emotional care for people through robot technologies where we haven't previously been able to roll out something in person.
That's wonderful. Roland, you had wanted to weigh in as well.
Yeah, just I have seen that somebody wrote, Kim wrote in the chat that that's what made Birdly so enjoyable. Birdly is actually somewhat a system where you can feel like a bird and fly through a virtual environment, like for example through New York. It's really a wonderful experience, which has also some feedback, some sort of haptic feedback. And actually, I don't know exactly if I'm allowed to tell this, but I will do it anyway. But we are in discussion with them. And of course, our dream and their dream is to have this Birdly connected with a real flying platform with a drone. And then you actually fly in real through New York and not only virtual. And I think this is the next type of excitation we can actually have in this type of telepresence and moving in augmented and real environments, but still physically being in a totally other place. And I think there's plenty of wonderful elements which will come up in the near future, where we, as a society, of course, some will probably be a little bit not very interesting, but I think some of them will be really exciting and change our life, and probably also how we explore environment. Imagine you go to Africa instead for a safari. Probably it would be even better to go to a safari on a drone and not be in physical presence, because you can get much closer to the elephants or the lions. So I think there is plenty of new elements which are coming up day by day.
That's and I think, like, if I can chime in also on this aspect, I think for us, Handshake and a lot of some other projects we've done, it's also about the actual knowledge that the experience is actually happening physically somewhere. Because Handshake could be just a chat. It could be just a chat, and people just like go online and control two hands on screen that are maybe like vector graphics. But the fact that you know that you're actually physically existing somehow somewhere really changes the experience. Or at least for us, that was what we felt was also very interesting, is that the encounter between two persons around the world is actually happening somewhere. And this completely changes the relationship you have with the situation, because I don't know, that's where exactly where our job as designer ends, and the cognitive scientists should take over. Like, what is the actual experience when you know that it's happening somewhere and it's not just a simulation?
But also really felt that when it was installed for the last couple of days in our studio, and we were working there, and we just like hearing the hands starting to move and actually knowing that now there is someone on the website, but it almost felt that someone would enter our studio, and it was basically that was
wonderful.
Super nice experience in a way.
Mm-hmm.
But I guess the knowing that someone now is controlling the hand added a lot of
I'm sure. So Roland, I didn't ask you about, what was your experience when you actually took hold of the hand and used that?
Yeah, so actually it was a short experience, but I think it's as usual, if you do something through a tool, and robot is in a way for me also as a tool. Humans are very good in all of a sudden seeing the tool as part of their own body. There is actually even a hammer can be at one point, if you are used to use the hammer, it's nearly a part of your body. And I think this is the same with this hand. All of a sudden you feel, you have the feeling that you feel the hand, even if it's not your hand, and it's not, even though without haptic feedback, sometimes you feel haptic feedback.
Mm-hmm. We actually worked a lot. The hands are so like wiggly, because that's the only way we could like really embolden the visual feedback of feeling the hands deforming and stretching. That was to really make it very intense, this feeling that the hands are really interacting by flexing, and you feel the pressure, you see the tension, the fabric is deforming because they are not very filled up. And that was really to make it very visually, visual cues. It's full of visual cues that you are actually interacting.
Yeah.
I love that you just did what has been termed the Rover Dance. And in fact, Janet Vertisi, I have her book here, and she was an anthropologist who studied the NASA teams driving the Mars rover. And she talked about the way people would act out the rover to communicate what was happening to the rover. And I was doing this with the handshake. And you talked about us taking, Roland and Steven both taking tools into us as an augmentation, an extension of our human body. We don't need to touch them to push ourselves into the experience.
That's really nice because, sorry, it's really nice because you just said that the visual cues, you want to change the visual cues so that people would feel more. So the gloves deforming actually shows it gives you a visual cue, and then that gives more emotion. And that actually is impact that when we have a social cues observed and actually have the physical interaction. So you're showing that you can really use robot as an interface to transfer visual cues to social cues that people appreciate and what we're missing in the virtual world normally.
Mm-hmm.
That's wonderful. You know, it's funny, you actually get ahead of me. Like I was going to ask you, like, what is your impact on how your work deals with relationships between human and robotics? And I think you just captured it there, right? It is kind of that helping people to feel that as an extension. And you know, robots have been extending people for a long time, right? Machines, automation. I think what this exhibition really shows is, but we don't often connect people with that extension, right? Unless you have a car accident or something like that. You're not actually physically connecting. And I think this is starting to show this next wave of where we're going to go with humans and robots and our interactions with each other through those pieces. Let's see, Roland, let's go to you with this question, but the rest of you will, I'm sure, weigh in. What does the future look like with an increasing robot population in the world? And I mean, we just have to go to the grocery store for self-checkout or see an autonomous vehicle going down the road to really start to feel this these days. This isn't even in the future, this is now.
Yeah, of course, I'm personally probably very strong in engineering. I'm doing engineering, and so my vision is always to build robots which can actually take over the jobs which humans should not do. Typically, an example is going into gold mines in South Africa, where people have to work 2,000 meters underground. It's about 50 degrees Celsius up there, down there. It's a very bad climate and environment, so we should have robots there. There is all the firefighter which are risking their life to go into the buildings. Probably you have seen there was recently a video released where they had a couple of robots really extinguishing a fire on the building. And I hope we will have more and more of these robots which help us first in our daily environment for avoiding risk to take over very dull and dangerous jobs. And then, of course, there is probably the other end, which is also the robot to make us more happy, to have that we have more fun. And I think this is another field where I think it's also important to watch out, because people have more free time, so they want an entertainment, they want to experience something, and this comes back to this augmented reality experience and telepresence, where I think we hopefully will also have a lot of robots in the near and further future.
Yeah, it's really fascinating to watch this time of the COVID pandemic, when we've all been kind of forced to be disconnected, and how much now people are really yearning to kind of make connections and use technology to try to do that. So it's kind of fascinating. Anyone else on that question?
I do want to double down on what Roland said about robots should do the dirty, dull, and dangerous jobs. There are so many jobs that kill people. That should not happen. And at the same time, we created robot processes, factory automation, and we decomposed a job that was a satisfying job for humans, and we turned it into tasks. The sort of tasks that robots are learning to do, and they don't yet do all of them. And it is incredibly sad to see a video of women in Vietnam putting socks one at a time onto a sock holder in a factory, or a meaningless task like that, while they're going to sleep, propping themselves up to just do that task. That is not a task that any human should be doing. And so I think that every factory job should be given to robots, because we've already taken it away from being a satisfying task for humans. And that is a key difference. Robots are only capable of doing tasks. Humans are capable of performing a whole lot of meaning around a task. They can manage, they can troubleshoot, they can just engage with other people. There is such richness to what humans bring to the equation, and we are wasting it when we have humans doing robotic tasks.
Yeah, we live in such an interesting time where automation is coming, and I think a lot of people are threatened by that because they see traditional jobs going away. But one of the things I work in the future of work is kind of this new move to a much more fluid, lifelong learning, gig economy generated kind of workforce. And what's really promising about that entire construct is individuals finding passion and actually finding meaningful work. And I think there is this nice trade-off. It's a painful transition, I think, but it is one of those things that's coming that's very fascinating.
Yes, this transition might be painful, but I always add on that robots are extremely complex machines.
Yep.
So this transition will be smooth because it takes a long time.
Yeah.
It will not be that disruptive. It will be an evolution, and this allows us really to get used to it, to decide ourselves as a society which jobs we would like to hand over to robots and which jobs we would like to do.
Yeah, it's really interesting if you look at automation and the way technology works, because the inclination is that when automation takes a human task, that is somehow taking away a job. But what we actually find is when we get robots and automation to do something, we actually do more. There's a great example I like to use is the Snow White, right? So Snow White was a animation that came out in the early 1900s. It was 2 million hand-painted frames to make that movie by 275 artists. We now have graphics tools that make that kind of work really easy to do. And so we could create that same animation with probably 5 to 10 people in the same amount of time. However, if you look at the latest animation, like Iron Man 3, that has 3,700 animators on the credits. We do more with technology than we ever did when we didn't have it. And that's going to continue with robotics. It's going to enable us to do more. So sorry, I'm actually not a panelist. I'm just the moderator. So I'm going to kick over. I'm going to kick another question, and I'll make this a free-for-all. Humanoid robots, right? So we see a lot of interest in both pop culture and in industry. And I know, Jamie, you've got some work in soft robotics, which is that kind of humanoid-ish looking thing. Is this ethical? Is this should we be making robots in the image of humans, and what does that bring up for us?
Ethics are, I can't talk about ethics right now because it really depends on which frame you're looking at the problem. And right now the problem isn't clear. Is getting inspired by nature a problem? I don't think so. If you're looking for a solution, you try to connect the dots in every single domain that you have learned, understood, and studied. But in terms of, do we really want to replicate human in terms of, you know, mechanical being like a robot? It depends on what you want to do with it. Personally, for me, I guess I'm a little bit biased because my studies in robotics started with making humanoids, human ocular motor simulator, and humanoid hand and arm. The purpose then was not to replicate a human nor a Terminator, but it was more toward to understand how human psyche changes the eye movement. And there was surveys, there were videotapes, but it was not very clear what kind of motions are induced by which muscle groups and how that actually impacts our vision of looking at things. So we needed a mechanical component, a mechanical counterpart of human eye to test that out. So one of the reasons humanoids has become a little scary is because there are a lot of movies that villainize the images that bear human. But at the end, what many of the scientists are trying to do is try to understand how human behaves and how our biomechanics work and how that impacts our functionality when we are experience injury or non-injury, but just to understand how we move all together, so that we can create technology and solutions that can improve the quality of lives.
I love that. AATB, I'm going to throw to you guys. I mean, you clearly made your robots. They're very simple, but they had a human hand. That was not, clamps. It wasn't this kind of robotic piece. You clearly wanted to mimic human. Talk a little bit about that.
Yeah, I guess we tried, but also we did I think we did also try to make it very graphic and very kind of very pop-like in a way. And I'm always a bit worried about these kind of like two attempts to make robots too realistic, that I always find a bit scary, or yeah, I guess it's a bit. We tried to kind of, we had a kind of a hand as the
right.
skeleton.
You stylized it,
and
right?
we tried to,
stay in the cartoon.
We tried to move on a cartoon side. And also, I mean, for example, also in, let's say, the color discussion, we had the kind of like skin tone discussion, because first we tried to attempt, like our very first sketch was having kind of a skin tone, but then obviously the question raised like what skin tone to use, and then, which, I mean, it's a very important discussion, but then we tried to, and I mean, it was even before the Black Lives Matters, but it was really like, oh, should we use one white hand and one black hand? But then we felt that it would be a difficult discussion, and then we tried to move away. So we like took a step and really went red and green.
Yeah,
so I think
it's fascinating because there really is this human reaction to what we're dealing with, right? So that's one aspect of it. But then there's also like, I think the more we make things human, that makes them relatable, right? So I can recognize a hand as a humanish thing, even though that we know that's not a human hand. I find that just fascinating. I know, if you look in the graphics world and in the virtual world, we're really starting to see deep fakes, the possibility of showing people that aren't really people. And that's going to be an extension of this too. Laura, you look like you want to jump in. I think we got a couple more minutes where we want to open up for questions. You want to open up now? Okay.
Well, we already see a couple of questions on the screen, which is about this humanoid and haptics and prosthetics. Yeah. And I want to quickly come back to this humanoid. I think it's, in a way, of course, it's probably at one point the dream of engineers to build something, because we are the best universal machine. But if you want to really do something which is useful today, I think humans are extremely complex.
Yeah.
We are very diverse in what we can do, but we are not optimized for specific tasks in most cases. So if you want to do something good for the society, you have to build robots which are not humanoids, which are very good in something, but were very bad in other things. I think this is one element. Of course, as an engineer, I always speak about functional robots. So the robot should have the function or the design so that it shows what function it has. So we did, for example, about 20 years ago, a big exhibition with 11 robots moving around. They had actually a face which looked somewhat like humans because we wanted to get interaction with humans. So they had 2 eyes because this was the function for this robot. But the robot in production line has no function for interaction. It just handles parts. Yeah. So these robots have not to be appearing as a human. But what is also extremely important, I think people are much too optimistic what is technology available today. So haptic is extremely difficult. Our fingers are wonderful elements. And I'm extremely convinced that within the next 20 years, we'll never have something getting anyway close to a human hand. Yeah. So it's dangerous if you build robots which actually at the end seems that they should do everything what human can do, but at the end they cannot at all. So they are limited. So I think machines should show themselves what they can and what they cannot. And so humanoids is somewhat dangerous in this direction.
So it's interesting. Andrea, yeah, I want you to weigh in here because there really is this
really say no humanoids. And I think Roland just expressed the reasons terribly well, because it overpromises and it underdelivers. And back to what Jamie was saying about how do we understand the ethics of something if we don't understand the purpose? For me, there is no purpose in building a humanoid unless you're aiming to somehow persuade people that you've done something that is more sophisticated than it actually is. And I think the problem that I see is that many people adopt the methodology that Roland talked about, which is that the form follows the function. But there are other people that take a mobile base and a tray that goes around a restaurant, and then they say, well, hold on, we want people to like it, we want it to look cute, and hey, I can build it, so therefore, let's put a head on it. Let's do other things. And they might not even be functional at all. And it crosses into that territory of we just want to make it look more, we want to make it look better. It's a deceptive practice in some ways. It's often done just purely thoughtlessly. I would like to see us say no humanoids unless there's a really clear reason. And to be doing biomimicry for research, that's a really clear reason. There are good reasons, but in general, I see it as basically being used as an advertising practice, as a deceptive practice.
It's so interesting though, because you can tell people are just drawn to want to do it, right? You see it over and over. People want, and maybe it's the science fiction part or maybe, but it's interesting you have these red flags because I think you're right. I think it's not even always this bit. We had a conversation in our earlier meeting about some of these digital assistants that you talk with, right? And sometimes they have say a female voice. Well, are you reinforcing giving orders to a woman, right? If you have an assistant that's a digital voice, a lot of people are abusive to robots. Are there norms that will arise out of that? My last question here, and then we'll
stereotypes. We risk reinforcing stereotypes. That
absolutely. Well, I tell you what, this has been amazing discussion. Let's open it up for the larger discussion. We've got several questions that have been posted. I think some of you guys have already started looking. Let's start with Alicia Narden. What would be haptic applications in prosthetics? For instance, if someone who can't use their legs can feel the movement by prosthetics that a person who can use their legs thanks to a haptic signal. Sorry, not a robotic expert, lack of jargon. I think you guys can see these too.
Yeah.
Jamie, you're probably our haptic expert, aren't you?
Haptic interface. So haptics is really the study of understanding what people feel through their skin. And skin feels temperature, shear, pressure, pain. There's one more. But this is actually a really legitimate question because people are looking, or the researchers are looking at what kind of haptic signals to give back to the skin. and normally to the either to the stump or different parts of the skin where they're not using for actually moving the prosthetics. So yeah, it's being studied, and the current challenge is how to provide haptic signal that does not interfere with your own intention. Because what you don't want to do is, if you're surprised by some action, or when you're emotional or your muscles are tired, then you might use that haptic signal for some controlling your haptic interface for your prosthetics to give a wrong signal back. So having a better interface is quite important. And the second is to understand what kind of signals actually mimic the best of what you want to feel, because everyone has different regions where they still have a sensitivity. So you have to selecting out which regions that you want to add this haptic feedback. It becomes quite important.
Yeah,
there is a lot of work in this field, and I think there will be progress, but it's also slow. I think one critical issue is that you cannot have a stable interface, which either it's on a vibration on your body, but then you have to remove it during night and so on. And this is very difficult, because on the other side, if once you have a stable interface, it might be then really directly connecting to the remaining nerves. Then human brains, we are extremely wonderful in this. We will actually learn. We could actually connect somewhat the leg to the arm, and we will actually learn that this feeling, what we get from the prosthetic leg, will be actually what we feel on the arm, will be from the leg. So humans can do a lot, but we have to first have stable interfaces, a brain interface directly or whatever. All this stuff is making slow progress, but I'm not so sure if we can be ready in the next couple of years, because it's very difficult to connect biology with technology in a stable way for long term, not only for one day.
Yes, I second that. There's a lot of really good exoskeleton companies at the moment, and I believe that's probably where the most in practice experimentation in this field is happening, rather than in prosthetics. There's a good half dozen exoskeleton companies in the Bay Area alone. And one of the things that they're learning is that there is no such thing as a person's normal stride, for example, because the people adapt within the space of a day. They adapt to the input from the technology. And so you have you have an adaptation in both ways. You have technology trying to, effectively you have to watch out for trying to create a normal that is no longer the normal.
Yeah. AATB, you guys have anything you want to add there?
Yeah, I think like I guess that there are many fields that we are interested in to pursue in our practice, and haptics is one of them also. Sadly we have little resources compared to large research institutions, but it's for sure we have done actually we teach a lot also. We give a lot of workshops in design schools, and we explore new technologies and new sensors that are available, but through the lens of design and the way we can prototype a little experimental machines or devices that can provide us new interaction, either in societal settings or just as personal experience. And we did a lot of concepts with like little buzzers, like the ones you have in your phones. And so we've done a lot of suits with tons of these buzzers, and then like connected to the internet or somebody else, and then like connecting some sort of information and then driving this. So we've done, let's say, much more practical experiments.
Don't you just want to go to a dinner party with these guys? Like, they're going to have all sorts of things to try on, and it bells, whistles, and lights is amazing. That's awesome. Yeah. Let's see, we have another question here from Jonas Brunswick. You already spoke about humanoid robotic design. What is the role that design plays in creating empathy and optimal functionality when developing robots?
So I think like maybe just to speak about more generally design and robotics, I think that for us what's been interesting is that we come really from the design world, and we have been a bit escaping of it, and like we landed in this robotics field, and really we are finding it very fascinating and interesting that the technologies that are being developed is really incredible, but at the same time, we feel that it would be also good for the robotics industry to have more robots or designers or artists to really question and to experiment with the technologies that are being developed, to really turn them into let's say polished interactions. Like we see a lot, we've been in conferences like industry fairs, and we've seen like all these tables were showing like research papers, results, PhD stuff, and it's really interesting. But it's often it's terribly and very poorly presented or wrapped as results. And I mean, for what we've been used to producing as finished experiences for a public, it's like extremely sad to see that sometimes the technology is really full of potential, but it's so poorly shown or presented, or turned as an experience. So we are quite interested in like all these collaborations that are being set up between our research institutions and opening their labs to artists and designers to really take this technology and then turning them into actual like I'm not going to say like games, because it's not, don't really but like without looking at them as technical feats, but and then going past the technical feat and then like really thinking about, okay, what can we actually do with this without looking at them as like technical achievements. I think that's a bit what we try to do. The practice is about taking all this new tech and then turning them into like sensible experiences for the public.
I've tried to integrate. Oh yes, you've given me so much inspiration, but I agree. Design and artists have already studied these areas, and having come from more of a design practice myself, the question is, how do we get better design thinking in the development of new stage robotics products, which are often done by very few people with very little money and very little understanding of the role design plays. And so the worst thing that can happen is that someone brings a robot frame, effectively the motors, the wiring, the sensors and everything, to a designer, and then says, here's what we have to work with, and pretty much your tolerances are down to about, you know, 1 millimeter or 2 in the production version. And they treat design like a skin, a graphic element that you add to something afterwards, as opposed to the foundational understanding of what do you include and what don't you include. And in fact, I'm raiding my bookcase here, but I don't know if I can show that terribly well, but this is
there you go.
For human robot interaction, the Disney animators Illusion of Life book that was it outlines 12 different mechanisms in which we can visually create the illusion of life that has been taken from the animation processes that you talk about. This is the animators that did Snow White way back when, and there are psychology experiments dating back to the 40s, I think, that show geometric shapes with no soundtrack whatsoever moving around for 1 minute, and everybody walks away from watching that little video saying there is a story. These are characters. These characters have different weights and feelings, and we have a story. So when you can create so much emotion with so little, then you know you can do so much with design, and you really don't need to kind of add all the humanoid bells and whistles to convey that.
Okay, we're getting down to the last couple minutes here. I've gotten an extension for us, so we can go a little over. Olivier actually answered this or asked a question that I want to do this as rapid fire, so you get like 1 sentence or 2 sentences to express the answer here for each of you. Ready? First, the joy that the panelists have about robotics is wonderful to see. So you should hear that because you guys are amazing. But are there any aspects about robotics or robots that scare you? Ready? Okay, Jamie.
Confidentiality, the data collection, and what the robots can detect and how it's going to be used and stored.
Roland.
I think what scares me most is with all technologies that this comes in the hand of the people which should not have robots in the hands, and they can do harm to others.
Andra.
Deceptive robots that really don't explain to us why they're doing what they're doing, or give us false clues so that we may convey personal data or develop wrong expectations about how they will respond to us.
Fascinating. And AATB, you guys get the last word here, so.
I was about to say quaternions scare me. But, like I think like, yeah, in the end, our studio, what we really strive for is to provide a different voice when the robotics industry is sort of, they are not the only one allowed to say how robotics should enter society. We want to be the flip of the coin that can be like normal people taking control of robotics as well and showing another way, or showing what also can be done else. I guess
that's wonderful. Okay, here's what I'm going to turn it back over to Laura here in a second, but here's what I'd like. Jamie, Roland, and Andra, I think you guys can get to the Q&A. There's one other question. If you guys would type in that answer, and we'll finish off with a written answer for Christian Sim. So Laura, back to you.
Thank you very much. Thank you to all of you. It was a very interesting and dynamic conversation. I loved it. I'm sure the audience loved it too. We were thrilled to have you on our panel discussion today. And now for the audience, if you want to hear more about the moderator and the panelists, we will be releasing a podcast on robotics through which we interview them in more depth. So make sure you subscribe to our newsletter through the Swiss Next Boston website. And also a quick reminder that the installation will be online through June 30th, and that we have another event coming up next week on the 17th in collaboration with the Swiss Embassy in Japan, featuring AATB and Professor Masahiko Hinami from the University of Tokyo and Kate Darling from MIT. Thank you all for coming. Have a great afternoon or a great evening, and have fun exploring the human touch via robots.
Thank you.
Thank you.
Thank you so much.
Thank you.